Remote sensing is a fascinating science that allows us to gather information about the Earth's surface without making direct contact. Using platforms like satellites and aircraft, remote sensing captures data by sensing and recording reflected or emitted energy. This multidisciplinary field combines optics, photography, electronics, and computer technology to analyze objects or phenomena from afar. The process involves three essential elements: a platform to hold the instrument, a target or object, and a sensor to observe the target. Remote sensing is classified into passive and active types depending on the energy source. Passive sensors rely on natural energy such as sunlight, while active sensors emit their own energy signals like radar or LiDAR. The working principle revolves around measuring electromagnetic radiation, which objects reflect, absorb, or emit uniquely based on their physical and chemical properties. This technology is widely used in geography, hydrology, ecology, and more. Remote sensing platforms are vehicles or structures that carry sensors, enabling data collection from various altitudes. Ground-based platforms like towers and kites operate close to the Earth's surface, while airborne platforms such as airplanes and helicopters fly within the atmosphere, collecting detailed images. Spaceborne platforms, including satellites and space stations, operate outside the atmosphere, providing global coverage for environmental monitoring and weather forecasting. Sensors mounted on these platforms are specialized instruments that detect and record electromagnetic radiation. Sensors are categorized as passive, active imaging, non-imaging, optical, thermal, and microwave, each serving unique purposes. Passive sensors rely on sunlight, while active sensors emit their own energy. Imaging sensors capture visual data, and non-imaging sensors record measurements as graphs or waveform. Optical sensors operate in visible and infrared regions, thermal sensors detect heat, and microwave sensors penetrate clouds and soil for all-weather data collection. Geographic Information System, GIS, is a powerful computer-based framework designed to capture, store, analyze, and visualize spatial data. GIS integrates hardware, software, data, people, and methods to manage geographic information efficiently. Hardware includes devices like GPS units and workstations, while software provides tools for mapping and analysis. Data forms the foundation, consisting of spatial and attribute information in vector and raster format. People, such as analysts and planners, operate and interpret GIS outputs, and methods ensure accurate workflows and analysis. GIS is widely used in engineering for site selection, infrastructure design, environmental impact analysis, transportation management, disaster preparedness, and smart city development. It supports green infrastructure planning, water resource management, energy optimization, and waste management. By combining real-time data from IoT devices, GIS enhances monitoring and decision-making, making cities more resilient and sustainable. Groundwater is the freshwater stored beneath Earth's surface, filling pores and cracks in soil, sand, and rock. It originates from rainwater that infiltrates the ground, moving through various subsurface zones. The unsaturated zone or vadose zone contains both air and water, acting as a pathway for groundwater recharge. Above the water table lies the capillary fringe, where water is drawn upward by capillary action. Saturated zone, or phreatic zone, is where all pores are filled with water-forming aquifers that supply drinking water, agriculture, and industry. Aquifers are classified as unconfined, confined, leaky, semi-confined, and perched, each with distinct geological structures and water movement characteristics. Hydrogeological properties like porosity, permeability, specific yield, retention, and storativity determine how rocks store and transmit water. Understanding these concepts is crucial for effective water resource management and environmental protection.